Have you ever held, perfectly made object and just wondered how it got there? How it went from just an idea, maybe just a picture, to this solid, precise thing you could actually hold?
Right.
Well, today we're doing a deep dive into exactly that. We're exploring the world of CAM software that's computer-aided manufacturing. And specifically, we're putting two versions of BobCAD-CAM side by side, Express and Pro.
Yeah, it's a really interesting comparison.
Our mission here is to really get under the hood. We want to understand how let's say, the built-in capabilities of these different software versions directly impact the precision, the speed, and, well, the final quality of a 3D part.
Yeah.
We're going to try and uncover those key differences between Express and Pro and really what they mean for you when you're trying to create complex designs.
Exactly. And it's important, I think, to set the stage a bit. Programming a 3D part, it's not just clicking print.
No, definitely not.
It starts with making a solid digital model, maybe from an image. Then you have to build all the necessary geometry around it, and then you generate these super precise toolpaths.
Those are the instructions for the machine, right?
Precisely. They tell the machine exactly where and how to cut. And as we'll get into, the software you choose, well, it fundamentally shapes that whole process, that whole dance between the design and the actual cutting.
Okay, so let's jump in with BobCAD-CAM Express. If that's our starting point, what's unique or maybe limiting about it for, say, 3-axis machining?
Well, the most striking thing about Express is its simplicity, which sounds good, but it also means it has only one 3-axis toolpath available. Just one.
Only one? What's it called?
It's called Slice Planer. So imagine you're programming a part, maybe like that bottle model we discussed.
Correct.
You start with roughing. That means setting your tool, the direction it cuts, the step over, how much it moves sideways each pass.
The overlap.
Yeah. Exactly. And the step down, how deep each layer is. Then you pick how the tool enters the material, like a ramp or maybe a spiral or just a straight plunge.
Got it.
After roughing, you do a finish pass, maybe with a 1/4-inch tool. And this time you wouldn't really use a step down. You're just skimming the surface.
Refining
it, yeah. And then finally, for little details, like maybe a logo on the bottle, you'd switch to an even smaller tool, use a much tighter step over to get that detail in.
Okay, that sounds logical enough for maybe simpler shapes. But where does that single slice planer method start to cause problems, especially on tricky surfaces?
Yeah, this is exactly where you see the limits. Because slice planer basically works by taking parallel slices across the model at a set Z height. Kind of like slicing a loaf of bread.
Okay, I can picture that. Flat slices.
Right. And because of that, it really struggles when the surface gets complex, curvy. What happens is you get this inconsistent step over. As the surface curves away or changes angle quickly, those flat slices mean the actual distance between cuts on the surface varies a lot.
So you get uneven lines or ridges.
Exactly. You can often see it. And that inconsistency means more time spent after machining, hand finishing, sanding, trying to smooth it out.
Right, post-processing.
Yeah, lots more post-processing. And the final finish just doesn't look as professional. Even after you do the roughing, the finishing, the detail pass, that core method, the slice planer, just doesn't adapt well to those fast changes in the surface shape.
That makes total sense. Trying to approximate a curve with flat slices isn't ideal. So, okay, switching gears then. How does BobCAD-CAM Pro change the picture? How does it, elevate the whole process?
Well, Pro is a completely different ballgame. It unlocks this really robust set of advanced 3-axis toolpaths. You're not stuck with just one method.
Options.
Lots of options, tailored for different jobs.
Yeah.
You get things like adaptive roughing, flatlands, equidistant pencil milling, advanced planer, a whole toolkit.
Okay.
It's worth mentioning, most of those are standard in Pro, but there's one super specialized one called Steep and Shallow that's usually a premium add-on, really for extremely complex parts.
Gotcha. So let's walk through that same bottle model again, but this time using Pro. What's step one? And you mentioned adaptive roughing. Why is that such a game changer?
Okay, so with Pro, you'd likely start with adaptive roughing. This toolpath is fantastic, especially if you're cutting tougher materials like steel.
Right.
Its big advantage is how it maximizes your tool life. It uses this very efficient circular high-speed cutting motion. It lets the tool cut deeper, but without putting too much stress on it.
So it removes material fast, but gently on the tool?
Exactly. And think about the economics of that. If your tool lasts, say, 3 times longer cutting steel, that could save a small shop thousands a year just on tooling costs.
Yeah, and less downtime changing tools, too.
Absolutely. Less downtime, more efficient cutting. It's a huge win right from the start.
Okay, so that's a smarter way to get the bulk material off. What comes next? How do you refine it after that?
So after the main adapter roughing, you'd often use something called rest roughing.
Rest roughing. Okay.
Yeah, it's a really clever step. It basically tells the software to only cut in the areas where the previous larger roughing tool couldn't reach, like the corners, the tighter spots.
So it's targeted cleanup.
Precisely.
Yeah.
It does two key things. One, it gets rid of that remaining material, which protects your smaller, more delicate finishing tools from hitting big chunks.
Makes sense.
And two, it massively reduces air cutting. That's when the tool's just moving through empty space where material's already gone. Rest roughing avoids that. It just cuts where needed. Big efficiency gain.
That's smart, only cutting where there's actually material left. Okay, now for the main finish. You mentioned equidistant. How does that stack up against the old slice planer from Express? This sounds like where the magic really happens.
You nailed it. This is the night and day difference. Equidistant. The way it generates the toolpath is fundamentally different. Instead of those flat Z slices, it actually follows the contours of the part. It calculates its path to always be an equal distance equidistant from the previous path along the surface.
Regardless of the curve.
Regardless of the curve or the slope. It maintains a perfectly uniform step over right across the whole surface.
Wow.
And the result? A vastly superior surface finish. Smooth, consistent, often needs very little post-processing. You mentioned direction changes too.
Yeah, you noted that earlier.
Right, with equidistant, the toolpath often changes direction with each pass, which also helps maintain that constant engagement and super smooth finish. It's constantly adapting.
So it's literally tracing the shape perfectly. That's a huge leap. Okay, one last piece. Those tiny details, like the logo on our bottle. How does Pro handle that level of intricacy?
For those really fine details, Pro typically uses something called advanced planer. This uses a smaller tool, obviously, but the key thing is it uses a variable step over.
Variable, so it changes.
Exactly. The software automatically tightens the step over in detailed areas, like the sharp corners or fine lines of a logo, and maybe relaxes it slightly on flatter sections nearby.
So it adapts on the fly for precision?
Precisely. It focuses the detail right where it's needed, giving you this incredibly clean, crisp finish, even on the smallest features. It's about tailoring the cut perfectly to the geometry.
That's incredibly sophisticated compared to the Express version. Okay, let's try and tie this all together for you listening. What's the big takeaway here? It sounds like more than just how the part looks.
Oh, absolutely. If you connect all these dots, the difference isn't just skin deep. It's not just cosmetic. It has a massive impact on practical things like tool life and your total machining time.
Right, the efficiency factors.
Exactly. Both the roughing, like adaptive, and the finishing, like equidistant and Pro, benefit hugely from advanced feed rate control.
Feed rate control, so the cutting speed.
Yeah, think of it like a smart cruise control for the cutting tool. The software ensures the tool is always cutting at the optimal speed and chip load for that specific material and the geometry it's encountering right at that moment.
So it's not just plowing ahead at one speed.
No, it adjusts constantly. It speeds up where it can, slows down in corners or heavy cuts to protect the tool and maintain quality. This prevents tool wear, avoids breakage, and maximizes how quickly you can remove material safely.
And that translates directly to
Better performance, lower running, costs less money spent on tools, less machine time per part, and ultimately just a much more efficient, competitive way to manufacture things. Choosing the right tool path, whether the part is simple or complex, it really does make all the difference. It's not just a setting, it's strategy.
Wow. So we've really peeled back the layers today on programming 3D parts with BobCAD-CAM. We've seen how that software choice, Express versus Pro, can genuinely transform an idea from just a digital file into a perfectly finished physical object. It's quite a journey from those basic slices to truly intelligent adaptive cutting.
Absolutely. And as you've heard, those details, the nuances in how a toolpath is calculated and applied, they really do profoundly impact everything, not just how the part looks, but how efficiently you make it, how long your tools last, how much it costs. It's a critical piece of the manufacturing puzzle.
It really is. So here's maybe a final thought for you to take away and chew on. As this CAM software keeps getting smarter, keeps offering even more precise, more adaptive ways to cut materials, how might that change what's even possible to make?
Yeah.
Think about things like, custom medical implants perfectly matched to a patient, or maybe incredibly complex parts for aerospace, or even highly personalized consumer goods. How will this relentless drive for digital precision shape the kinds of entirely new products we might see in the future? Products that maybe today we can barely even imagine because they require a level of perfection that's just now becoming achievable.